The ideal gas law is found on page 2 in your packet, and there are several problems for the ideal gas law. You'll see them on page 2 and on page 3. For today, we're just going to focus on question C. So what I've done to make things a little bit smoother for you, since we're only going to focus on one question today, just question C, I've gone ahead and transferred over the really critical things that you need for today to help you solve the problem. So at this point in time, I would encourage you to make sure that you have these written down somewhere on your page, either on the worksheet itself, wherever you can find room, or ideally in your notes. Remember, you never need to print out any of these questions. You can just rewrite the question or label the page ideal gas law and label it part C and answer just straight on your paper. Okay, so I have the general equation for you, and I've written that out in blue, and I've also included in red the specific units that you need. That's on the left side of the page. If you look at the right side of the page, I have the formula written out for you in blue as well, but this time I went through each variable and rewrote out specifically what that variable was referring to. Highlighted in gray, I have R, your constant, and remember this will always be provided for you, and I brought over two conversions that are going to be helpful for you to solve any problem for the ideal gas law. So the conversion between milliliters and liters, 1,000 milliliters always equal to 1 liter, and then going from Celsius to Kelvin. Okay, at this time, I'm going to start working through question C. Question C says, what volume, so I know I'm going to be searching for a volume. Let me go ahead and just label that. What volume does 4.24 grams of nitrogen gas, and I'm being reminded that nitrogen gas is diatomic, so I know it's N2, not just N, occupy at 58.2 degrees Celsius, so clearly this is going to be my temperature, and 2.04 atm, this right here is going to be my pressure. So the grams part right here, I'm going to have to convert grams into moles. And so right over here, if this is on your packet, then just do what I'm doing and cross it out. It's not necessary for you. If it's not on your packet and I made you a copy from a different page and it just gives you the molar mass and it says 28.02 grams per mole for N2, then that's all you need for today. That's all that's important for you. So remember, the molar masses will be given to you. So since we were given grams and we're going to have to solve for moles, you already know that when you're going to plug in N for moles, you're going to have to do a little bit of your conversion. Okay, we're ultimately going to be searching for volume. So if my formula is PV equals nRT, I have pressure, it's 2.04 atm. I'm looking for volume. I have the number of moles. I'm just going to have to go from grams to moles. And I have temperature, it's 58.2 degrees Celsius. I'm going to have to convert that to Kelvin. My R is always a constant. I'm always going to have to plug in 0.08206. So what I'm solving for is volume. So I'm just going to walk you through isolating the variable if you need that help. Remember, that means I'm going to divide both sides by P because P is hanging out next to V for volume. That gets rid of my pressure, and I'm left with the formula that I want, which is volume equals nRT over P. Now what I need to do is take the time to plug in each one of my variables to the formula. So I'm going to start with N. And remember, N is equal to number of moles, and you always want to keep your conversions in the actual formula that you're solving in. So I wasn't given moles directly, I was given grams. So I'm going to take the grams they gave me, which was 4.24 grams of nitrogen gas, and they specifically reminded me that it's N2. I want to get out of grams and into moles, So if you will remember, that's something that we really focused a lot on the beginning of second semester. Going from grams to moles, you always just need molar mass. So I'm going to write down my molar mass. Remember, it's 28.02 each gram, 28.02 grams for every one individual mole of N2. I want grams to cancel, so I'm going to say 28.02 grams in my denominator, and I'm going to write 1 mole in my numerator. Normally, we would take the time to write out N2. I'm not going to include that for this. You're welcome to do so if you feel better. I'm just trying to conserve a little bit of space here and make it less congested. So now what would have happened is my grams and my grams cancel out, and I'm left with moles, which is what I want for N. I'm going to go ahead and move on over to R. R is my constant, so it's always this value, 0.08206, and your units, you say liters times ATM over Kelvin times mole. And remember what I talked about in the last video, you don't need to put the multiplication sign. It's not important. You just want to make sure that you keep your numerator correct from your denominator and you're not flipping those. You're not flipping the numerator with the denominator. So now I need to move on to temperature. The temperature they gave me was 58.2 degrees Celsius. Remember, I want to convert this to Kelvin because anytime that I give a temperature, it must be in Kelvin. That's just an absolute law for any gas law equation, including the ideal gas law. So to go from Celsius to Kelvin, I need to add 273. So now what I've done is I'm essentially in units of Kelvin right here. Going back to my formula because now I'm done with the numerator. Now I just need to put in my denominator. My denominator is just the pressure. The pressure they gave me was 2.04 atm. I didn't list out any of the conversions for pressure for you at the start of this video because it's not necessary. And so we were given units of atm. Anytime that you use pressure in the ideal gas law, it has to be an atm. So there was no need for any conversions to be listed. Okay. Check your units now. So let's go through these one by one. We had already cleared out our units of grams and we know we're left with mole. And remember for temperature, we're sitting and looking at units of Kelvin. So now watch how this works with removing units, with canceling units. I'm going to start first with the moles that I used in my conversion for molar mass, because remember, that's now the unit that I was remaining in. I got rid of the grams. That's in a numerator. If I go next door to R, I have moles in the denominator. All this time I'm still hanging out in the numerator of the entire formula, but notice that I have moles in the numerator and moles in the denominator. So what that means is those guys have now canceled each other out. I'm going to now transition over to temperature. And remember, temperature got converted over to Kelvin right over here with plugging in our temperature formula. That's right now in my numerator. If I look next door again at R, I have Kelvin right here in the denominator. So I have numerator, denominator. Those units are now going to get canceled. My last unit that I'm going to be focused on is the unit for pressure, and remember it was ATM. So I have ATM right here in R in my numerator, and I have ATM for my pressure in the denominator. So this one is just what you always know to do, a numerator with a denominator, the numerator and the denominator cancel. Notice you only have one unit remaining, and that unit is liters. And look where it's remaining. It's remaining in the R constant. So remember what we had always talked about. Whatever unit is remaining in your formula or in your string equation, that's the unit that you're going to answer in. Notice that the question didn't specifically tell you what volume in liters. It just said what volume. So this right here is your unit of volume. And it's going to be in liters no matter what, because all you had left was L for liters from the R constant. So now it's time to plug all this into the calculator. And this is where, if you kind of struggle with that, this is where things start to get a little bit messy. And so I'm going to take this step by step. Here's the first thing that I would do. I would go ahead and just take my molar mass and plug this into my calculator first. So I would do 4.24 divided by 2802. I would get my answer. I would write it down. In fact, I would just write it down right above here so that you have a reminder of what that messy long decimal is. If your scientific calculator is saving these values for you, then it's a lot less writing down. You can just go back up to the screen and see what the number was. The next conversion that I would take care of would be the conversion for temperature. So I would now take my time and go to my calculator and say 58.2 plus 273, and I would take the time to just write out what that answer is, either on my paper, right where I have the little black dots, or if you have a scientific calculator that saves the numbers for you, then you can just scroll back up and see what that number is. So here's now what you're going to want to do. You're going to want to make sure that you now take your answer that you got, converting grams to moles. You're going to multiply that by 0.08206, and then you're going to multiply that to the answer that you got for Kelvin. Once you multiply those three values, hopefully your calculator is looking back at you with the number 4.112629131. If it's not, you took a misstep. So go back, take your grams, convert it to moles, separately take your Celsius, convert it to Kelvin, and then separately take your answer that you got for moles times your R value times your answer that you got for Kelvin, and this is the number that you should be left with, looking at you in the calculator. Your denominator is strictly 2.04. So all you're going to do now is say 2.04 for your denominator. I'm going to now leave you with having to get the calculation answer and then finally the sig fig answer. And so I just want to take a moment and make sure we remember sig figs and how to account for those. If you remember for temperature, we said never look at temperature for sig figs. So that's why I crossed that out. What you are going to want to be comfortable with for sig figs is this guy right here, your 4.24 grams. You want to make sure that you remember that this is 3 sig figs. Then you're going to go over to your pressure, which was 2.04 atm. This again is 3 sig figs. You didn't have any other data. Molar mass is a conversion factor, so it's not included as data. So for this question, you have 3 sig figs for grams, and you have 3 sig figs for pressure. So that means that your final answer must be in 3 sig figs. And then don't forget your unit. You worked through all this and you did all these conversion factors to make sure you identify the correct units, which I just circled there for you in red. So this is all you're doing for today. When you're done with all this, make sure you've given me your calculation answer, your final answer in sig fig, box it and circle it, make sure it's labeled correctly, that you're telling me this is ideal gas law, and you've labeled the question as part C. This is then what you're going to submit to Schoology today.